Okay, so this video is just going to show how to use VLOOKUP to add outdoor air temperature to a data set if it didn't have it. I mean, you can use VLOOKUP to do a bunch of things. That's what I'm going to do with it in this example. And, do, do a couple other quick things that are related to the scatter plot thing we've been talking about, just to illustrate some techniques. But basically, say you had a data set. This is a set of data from a data logger where I've picked up heating coil discharge temperature and a cooling coil discharge temperature. It's a 100% outdoor air unit. And if I wanted to know the load on the heating coil, it's a constant volume unit also. If I had a flow measurement and I had an entering air temperature, which on a 100% outdoor air system is the outdoor air temperature, I could, calculate the load on this coil, and then since this is the air leaving this coil becomes the air entering that coil, I could also calculate the cooling load. But to get started, I needed an outdoor air temperature, and this is a project in Golden, Colorado. And so basically, there's a bunch of ways to do it, but excuse me. One thing I could do would be use Bill Cran's weather data query. And so if I go and get that file and I pick Colorado, and then I see what my choices are once I've picked Colorado. Let's see if there's anything. Golden's really close to Denver, so if there isn't, I think there's a little airport near Golden, but if nothing else, I could pick the Denver International Airport, and I would probably be pretty close here. And truth is, I might be able to narrow this range down by going to, let's do that. Let's go to the National Weather Service site and type in Golden, Colorado. There is a Golden, Colorado. Let's say go. And a couple things. I could say, let's look at the 3-day history, because I think when I do that, it'll tell me where the weather station is. Broomfield, Jeffco. So let's see if there's anything that looks like that here in this list. Colorado. And truth is, I don't want to sit here with a bunch of dead air time. You get the idea. If you go to the National Weather Service, you can see what weather they use if you ask for Golden, Colorado. You also could use this local weather station thing to see what are the airports that are nearby. And they list Denver International Airport as one of the nearby weather sources. And so if I was doing this, for a job, I'd probably try to find the closest airport I could to Golden. But just to illustrate the concept, I'm just going to pick Denver International. Okay, so I've picked that. And so now I go back, and the date range I'm interested in is basically November 27th, 2012 through November 28th, 2012. In other words, so maybe I'll get the 26th through the 29th just to be, make sure I have the base covered. So I'm going to pick in here 11/26/2012 and 11/29/2012. And I'm going to keep the hourly, and I'm basically going to say let's retrieve that data. And so it's off thinking about it here for a minute. And it's done. Now if you ask for a year, it'll take longer than that. But basically, there's my data. Okay. And so now I'm going to move that data, or copy it. You probably want to copy it. If you move this tab, it kind of breaks the spreadsheet. So I'm going to copy that data into my example. and at the end. Okay, so now, here's the data from the loggers. I'll label it logger data, just so it's clear. That's what that is. And now here I have a table which, for every hour of the day, I have, documented the temperature and the dew point for, the Denver International Airport. So all I have to do is, get those two screens beside each other and then look up this time in that table and then make a column here. So now I got a column and so all I got to do is look up this date and time in the other table, find the outdoor air temperature and type it in here, right? And just do that for the, couple hundred rows that I have, and I'll be able to do my calculation. Oh, it's 1600 rows. So I just have to do that 1600 times and I'm good to go. So I'm being a little silly, right? That'd be extremely tedious, right? And that's the value of VLOOKUP. I'm just gonna make these a little wider so the text wrap doesn't cut things off, and I'll center everything, and I'll format the numbers for 1 decimal place. A comma. So that's what VLOOKUP is handy for. Basically what I can do is I can tell Excel, instead of me doing it manually, I can say, no, go to this table and look up the outdoor air temperature for the hour that corresponds to this data set, because this is 1 minute data. So 60 of these samples correlate with 1 outdoor air temperature from the National Weather Service. So how I do it is I get in that cell and I say equals VLOOKUP. So there that function comes up. So I pick it, double click on it, and that lets me use this to pick the data. And it says, well, what do you want to look up? Well, what I want to look up is that date and time, okay? And then the table or array, that's where you want to look it up. And so now, basically, when you tell VLOOKUP where to look, the first column in the array that you pick or the table you pick needs to be the column that has this piece of data in it. So I'm going to go to my weather data tab, and I'm basically going to, there's the date and time, I'm going to make that my first column, and I'm just going to pick everything. So I clicked in the first cell, I arrow keyed over. Now I'm going to hold, I held the shift down and I used the right arrow key, and now I'm going to hold control down with shift and a down arrow, and that picks up all that stuff. So that's the arrange. And before I leave here, I want to look at, relative to that first column, where is the information I want. So there's first, second, third. So it's in the 4th column. That'll be important here in a minute. So I'm going to accept that as the range. Oops, I shouldn't have closed it because it's giving me an error message. It's saying you didn't tell me enough, and that's right. I didn't tell it what column to look in, and that's why I was checking that out. Basically, I want to use this table, and I want to look in the 4th column, okay? I can leave this blank, or blank and true are the same. And basically, if I leave it blank, it'll pick the closest value and won't look for an exact match. And so most of the time we want the closest value. If you really want an exact match, put in false. But an exact match is literally an exact match. And you got to remember that, we're looking at a date and time over here that's formatted to the minute, but there could be seconds in there. So if I picked this and the Weather Service didn't match it to the second somehow, it wouldn't return anything. So I usually leave this blank unless I really, really, really want an exact match. Okay, so I say okay, and sure enough, it's gone and looked up the temperature for this hour and returned it to me, which is good. That's what I wanted. Now, one other trick, because what I'm going to do is I'm going to paste this formula into all 1600 rows. This address right here, this basically, that's saying look on the weather data tab, and the table is in a range from B4 to F107. That's a relative address. if I copy that formula down a cell, watch what happens. Now it's B5 to F108, and now it's B6 to F109. So it keeps moving the table, the place I'd look, down. Well, the problem is, basically, after 109 rows, I'd be looking at the spreadsheet where there wasn't any data, and I'd be clipping the data in every cell. So I want to make this, before I copy it, I want to make it an absolute reference. So let's just show you what that error looks like. I'm going to go ahead and Control C, click in here to find the bottom. I'm going to do Control down arrow. I'm going to arrow over one cell. I'm going to do Control Shift up arrow. Let go of Control down arrow once, and I'm going to paste that formula in. See all these NAs? Well, that's because basically VLOOKUP is now looking at the range from B1116 to F1714 on this weather data tab. And if we go down there, there's nothing there. Okay, so that's because it used a relative address. If we lock that down to an absolute address, and that's really easy to do, you can either manually enter a $sign, or if you just ahead of the cell references, or if you just highlight that and hit F4, it'll put the $signs in for you. The $signs lock you to those specific cells. So now watch what happens when I copy this formula now. When I copy the formula to here, I'm just going to do it to all of them. Notice that the formula is the same in every single cell in terms of where it's looking for the data. Okay? It's changing the reference. In other words, it's saying look for this cell, not this cell, because I didn't make that an absolute reference. I let it alone. I let it be a relative reference. But it's saying when you go over onto this weather data tab, look in exactly this range. And now, you know, if I page down through here, or in fact go to the end, I do have data there instead of the NA. So that's how you use VLOOKUP, which is sort of the core that I wanted to show you. But just another little example of, now that you have this information, what you can do with it. There's basically a fundamental energy equation that's real handy, and there's a link on the side of my blog to these equations. I'll show that to you just so you know about it. If I go to my blog here, I suspect a lot of people that use this blog know these equations, but if you don't, if you click here, it'll link you to a bunch of slides that include all these equations, and I have them stored in my computer because I teach a lot and so I use them. So I want to get the equation for sensible energy, so I'm going to say open, goes to my directory, and PQRS, sensible load. Okay, so basically this equation right here, I'm going to copy it in my spreadsheet. It's always a good idea to put the formula you're using in the spreadsheet, so if somebody besides you looked at what you did, they could figure it out. So there's the formula I'm going to use. Q in BTUs per hour is equal to 1.08 times the flow in cubic feet per minute times the temperature difference across the coil. And so if I wanted to calculate the load on this heating coil, I could use that equation to do it now that I have the entering air temperature. I know the flow in the unit was steady, and it was a constant volume system, and it was, I'd have to go look it up, but it was in the range of 2,000 feet a minute, or 2,000 CFM. So I'm going to put 2,100 CFM. I believe that's about right. And again, if this was a job I was doing, I certainly would, make sure I had that right. I'm just trying to illustrate a concept here, so I'm not going to worry so much about having the exact number. How I got that number, we did a little pitot tube traverse. You could have traversed it with a velometer across the coil face or across the intake louver. Each of those has its pros and cons, but this was based on a pitot tube traverse, so it was actually a pretty good number, the actual number we used. And so let's just stick that formula in here. So the BTUs per hour is basically equal to 1.08. Now, a little subtlety here. In Denver, that correction factor, that factor right there is the 1.08 in this equation. That's a units conversion constant for dry air at 70. In Denver, you're a mile up in the air, and one of the things in this constant is density. And so I need to correct that constant because I'm doing work in Denver. And it turns out it's pretty much a function of atmospheric pressure. That's the thing you have to take into account. And I actually, since I do this a lot, I've built a little spreadsheet that does it for me, which I'll put up on I'll link this up on the blog so you can get to it if you want to. Let's see here, where do I have that? Oops, here. I think it's in a folder called Standard Atmosphere. It's not there. I forgot I needed to make this correction, or I had this open already. Oh, there we go. Air density and properties. I believe it's in there. Yeah, standard atmosphere. So I basically have this little spreadsheet, and basically it just has, you know, a bunch of stuff about how atmospheric pressure varies with altitude. And I used that data to develop the equations, just like we were talking about with scatter plots, but I used the trend line feature to develop the equation. And then I built myself a little tool that basically lets me put in the altitude, and Denver's about a mile up, and gives me a correction factor. So I want to correct that 1.08, I want to multiply it by 0.82. And like I said, my point here wasn't to get into this so much as to show a technique, but in showing that technique I realized I needed to make the correction. That's a really important thing when you're using equations with units conversion constants in them, to make sure you adjust that constant appropriately. And so our correction factor for altitude is going to be 0.82. Okay, so now we can go ahead, and so basically we're going to add the correction factor here. So it's equal to 1.08 times our correction factor, and I want to lock that down to an absolute reference. So I'm going to hit the F4 key because I'm going to copy this equation down that whole row of cells. So it's 1.08 times the flow rate, which I'm also going to lock down to an absolute reference, okay, times the temperature difference across the coil. And the temperature difference is going to be basically the warm air minus the outdoor air. So there's the delta T. So there's the equation. Now, right here, the logger wasn't in the unit. It was sort of, I was just checking calibration, how well the probes agreed, and they agreed pretty well. So I actually decided I didn't need to do a correction factor for this logger. Sometimes, like if these are off half a degree, like I'm logging temperature concurrently, if they're a half a degree different, I'll adjust one of them. I'll add a column here and I'll correct one relative to the other so that the delta T is a true delta T. And in this case, like I said, I decided not to worry about that. I'm going to format this to no decimal places with a comma. And again, this is now in BTUs per hour. And the other thing that can happen is as these temperatures approach each other, you get zero or even, you know, what looks like a temperature drop across the heating coil, a negative number. So I'm actually going to, and I know that can't happen, so I'm going to say basically if basically the delta T, if basically the difference between the leaving air temperature minus the outdoor air temperature is greater than 0, then go ahead and do this formula. Otherwise, just put a 0 in for me. Okay, that'll sort of solve that problem. So the other thing I need to recognize though is this is BTUs per hour, but that condition is basically what occurred, you know, for a minute. paste it down here, it's a slightly different number. So that's how many BTUs per hour we'd consume if this coil saw this delta T for the entire hour. But I want to know how much energy it used in a minute. So I have to correct this I have to divide this by basically 60 minutes in an hour to get how many BTUs I used for this one data sample. Now, I could literally just say I'm going to divide this number by 60 and get it. But sometimes loggers hiccup, or if you're using trend data from a building, there's the controller's down for an hour. And so if I say it was down for an hour and I divided by 60, that wouldn't be right anymore. And so I usually build a little formula that uses the date stamps to come up with the sample interval just in case there's a hiccup and there's actually more than a minute between samples or the data set isn't consistent. So the sample interval in days, because remember from the other videos in the posts leading up to this, this number, it looks like a date. But if I paste that number as a value into the cell, it's actually a number. Remember, Excel's working with dates. It gets a date by formatting a serial number. So if I subtract these two numbers, that's the serial number that corresponds to the sample interval. So basically, if I go into this cell and say the sample interval in days is equal to this minus this, that's how many days 1 minute is. And so then to convert that I think, yeah, okay. So we have this many BTUs per hour occurring for that fraction of a day. So I multiply this by 24 hours. So that's basically equal to this times 24. So it was basically that many hours. Wrap that. And so the BTUs I used for that minute are basically the BTUs per hour times the number of hours. So it's equal to this times this. So I used about 618 BTUs. And just like we know that was 1 minute, so this should be whatever that is divided by 60. So we can just do a little quick check. Take this, divided by 60, make sure I did the time conversions right, and I did. Okay. So the advantage, and again, I could have literally just said, we'll make a column, divide this by 60, but the advantage is if I skip 4 or 5 minutes because of a logging problem, this will automatically compensate for that. And so that's why I do this. Center this, oops, I want to keep that, center this. So now, and I'm going to basically format this because I don't know the BTUs to that many decimal places. Okay, so now I've got this set up. Control C. Oh, I forgot to, okay, sorry. Control C. I didn't highlight the cells. Something's hanging up my computer here. There we go. Down arrow. Shift up arrow. Oops. Okay, so I'm going to start this again. Okay, so I'm going to copy those cells. I'm going to go into that cell to find the bottom of the spreadsheet. I'm going to hit Control down arrow, which finds the bottom of the spreadsheet. I'm going to right arrow over. I'm going to hold Shift 2, 3 to get the 4 columns I want to paste into. I got the Shift down. Now I'm going to hold Control with Shift and up arrow, and then let go of Control and down arrow 1, and then say paste, Control-V. So now, basically for every interval, I've calculated how many BTUs, and so basically that's the load on the coil minute by minute. And so I could add it up for a day and say how many BTUs I used in a day. But my point is, by taking the log data and using VLOOKUP to get the outdoor air temperature, I could associate hourly outdoor air data with 1 minute logger data, and then once I had that, I could actually do a calculation with it that showed me the load. And I'll show you in some screenshots of slides what we did with that. It was really powerful. We basically could do a curve fit for that, project the load for a year. And let me just show you a couple things here before I quit. I'm going to insert 2 rows. I want to look at the maximum and minimum outdoor air temperature which we saw during this data set. Minimum. Okay, and I showed you this technique on the other videos, so I'm just going to do it real quick. I'm going to pick max, and I'm going to look at this range. And I'm going to do the same thing, min. Oh, I forgot to put the equal sign in. Computer's acting funny here. Let's. Equals. Well, that's weird. I'm not sure what's going on here. Let me save this. I've actually seen this problem happen before. I've never totally understood it, but it's like Excel quit paying attention to what I was saying for a minute. So I don't want to have to reshoot this whole video. So I'm going to shut Excel down and restart it here. And if that doesn't work, I'll just talk through it. So I'm going to close it. It's not even letting me do that. This is a very strange problem here. Close this. Yeah, it lets me do that one, so I don't save. Close that. There's something hung up there. Let's close this. Lets me do that. So don't save. Now it's let me don't save. Now let's see if it lets me do things. Yeah, I don't know. One of the spreadsheets must have been hanging me up. So equals min, same range. There's a method to my madness here. I'll show you in a minute. Okay, so for this data set, even though it was just like a little over a day, I actually saw a temperature span of 28 to 57 degrees. So if we go, and I had mentioned this in the other blog posts, if we go to the, I'll just step back through it just to re-illustrate it. If we go to the National Weather Service homepage and put in Golden, Colorado, what I'm trying to find out is, in Golden, Colorado, how representative is that span of temperatures to the span of temperatures you see an entire year? So I'm going to say go. And now I'm at Golden. And so the reason I went to there is I want to see where their forecast office is. I go here. And a lot of times the forecast office have the little nomographs I'm looking for right down here, but they don't in Golden, which gives me a chance to show you where you probably will find them. If you go, all the forecast office have a page that has climate and past weather, and you hit that link. And those links all, anytime I've done it, look pretty similar. And if you go to local data and records, and if you pick the Denver local climate page, now you're to where you can pick up those nomographs. And so like there's a bunch of different stations in Colorado. I'm going to stick with Denver, and I'm just going to look at what the temperature year looks like. Okay, that's going to give me a month. I need to keep the combo to get the entire year. Okay, so here's the normal band of temperatures in Denver. You have a low in the teens and a high in the upper 70s. We collected data and it was between 28 and 57. So we actually saw a significant range of the temperatures that occur in Golden. And granted, it's not as good as having actually log data when it was 20s and log data when it was 80, or log data even on an extreme day. But what I'm trying to say is if I'd been logging data and it had been a very stable day, like where it just sort of sat there at 50 to 60 all day, my projection of energy consumption, if I did a curve fit off a scatter plot of this data, wouldn't be as good as the projection I might get if I did a scatter plot. In other words, basically if I plotted load as a function of outdoor air temperature, we'll do that real quick here, and then I'll stop because I think I can illustrate the rest of this pretty easy with words in the blog post. So I'm going to insert a scatter plot, select data, and I'm going to add data that's going to be preheat load, let's say preheat BTUs per hour versus outdoor temperature. And so my independent variable on the x-axis, boy, my mouse is acting funny too. My independent variable on the x-axis is going to be the outdoor air temperature. And my dependent variable on the y-axis is going to be the load. And I say OK. And so there's my scatter plot, which there's kind of a cloud, but there's these little solid lines. You think, what the heck's that? But remember, when we're looking at these scatter plots, we don't really know if there's, we don't know if there's 100 dots on top of each other there or 10. And that's where that shading technique I showed you comes in handy. I'm going to narrow the scale and down here a little bit. So it's like 20 to 60. That'd probably work. And let's format that data series. And we want to mess with the fill and lines on the marker. Let's make the markers a little bigger. So I'm going to pick a built-in marker and make it maybe a little bigger. And I'm going to turn off the lines. That's an important step, because if you don't turn off the lines, the transparency trick doesn't work because the line doesn't go transparent. You could make the line transparent too, but it's just as easy to turn off. And then pick a solid fill, and just so it sticks out a little bit more, I'll use red. And the trick, of course, is the transparency to like 95%. And so what we got out of that little exercise is we can see, yeah, most of the data is in a cloud like this. Those were just, and actually no, in hindsight, that's when they shut the unit down once. Here it tripped on a freeze stat, and here they shut it down to work on it. So that's just the temperature changing because the unit shut down. And then the unit came back online. So we could filter those out, or we could just do a curve fit off of this real quick. The way you do that, select the data, add a trend line, and for our intents and purposes, a straight line's a pretty good fit. The R squared's not bad. So we could actually, for the year, project the energy consumption based on this data set right here. Now if I expand this scale, there's another clue about an opportunity here. I'm going to expand the axis up to maybe 100 degrees because we know it gets up to 80 in Denver. So I expand the axis up to 100, and we know it could get as cold as 0. You would expect a preheat load to vary pretty linearly with outdoor air temperature. So the fact that a straight line is a reasonable curve fit, that's not a surprise. But what is a clue, if we're trying to make, and this unit was trying to basically to deliver air at neutral air at about 70, 72 degrees. So if we're trying to make air that's 70 or 72 degrees and everything's working right, you would expect this line to cross the x-axis at that set point. In other words, when the outdoor air temperature got up to that set point, the preheat process would be shut down. And you can sort of see, and like if you wanted to eyeball it, you can add a line here. Let's add a line on top of that trend line. Or actually, there's another way to do that. So I was going to draw a line in and then move it, but there's actually a way. If I right click and say format the trend line, and if I say to forecast forward, and I forget what the time interval is, let's say 10 periods. Okay, let's make it 30 periods. Basically, I can shoot that line down to 40. And so I can basically shoot that line down and discover that, heck, that line doesn't cross the edge. So it's going to be, if the system continued to work the way it worked when we were logging it, it's going to be making preheat until it's 90 outside, and we need it to shut down to its 70. So you could get a real rough idea of the savings just by taking this line, finding the equation of the line that goes through 70 degrees at the same slope, and subtracting the two. And so I'll stop here with the video because I can show you the result of that with some screenshots of the actual data. But I thought I would just use this video to walk you through how to use VLOOKUP and then some tricks you could do with a data set for unit performance instead of whole building energy consumption.